Today we have an exciting story that takes us to the heart of the Milky Way to explore the mystery of Cygnus X-3. This extraordinary X-ray binary system has puzzled astronomers for decades, but thanks to recent observations, we may finally have some answers. Let's take a look at the incredible findings about why Cygnus X-3 is so bright. Cygnus X-3 is a binary system located about 24,000 light-years away in our Milky Way galaxy. It contains a massive star and possibly a black hole, and together they produce intense X-rays. Discovered in the early 1970s, this system immediately stood out because of its powerful jets emitted at close to the speed of light. These jets appear and disappear, adding to the curiosity surrounding Cygnus X-3. The new findings come from an international team of astronomers using NASA's Imaging X-ray Polarimetry Explorer (IXPE) spacecraft. The team explains how Cygnus X-3 enhances X-ray emission in the funnel-shaped area around the possible black hole. This discovery helps us understand how this system could be so bright and draws comparisons with some of the brightest quasars in the universe. Quasars are incredibly bright objects powered by supermassive black holes at their centers. They can sometimes exceed the Eddington limit, a theoretical limit that controls the speed at which matter can enter a black hole. Cygnus X-3 appears to exhibit similar behavior, but on a smaller scale. The Eddington limit suggests that if the accretion rate is too high, the flow of matter stops, and some matter is ejected out in jets. Cygnus X-3 appears to exceed this limit, maintaining its high brightness while continuing to accrete matter. A team led by Alexandra Veladina from the University of Turku in Finland used IXPE to measure the polarization of X-rays from Cygnus X-3. The high polarization levels indicate that X-rays are scattered from a funnel-shaped cavity in the center of the accretion disk. This funnel-shaped cavity acts like a megaphone, amplifying the X-ray emission. We discovered that the compact object is surrounded by an envelope of dense, opaque material, Veladina said. The light we observe is a reflection of the inner walls of the funnel formed by the surrounding gas, and it looks like a glass with a mirror inside. This finding aligns Cygnus X-3 with ultra-bright X-ray sources, ULXs, which are often observed as bright spots in distant galaxies. The emission of these ULXs is enhanced by the focusing effects of the funnel-shaped cavity around the compact object. Cygnus X-3 serves as a closer model to study these distant ULX and offers astronomers a unique opportunity to better understand them. Study team member Juri Putanen explained. ULXs are typically observed as bright spots in images of distant galaxies, and their emission acts like a megaphone, amplified by focusing effects around the funnel of the compact object. But they appear relatively faint in X-ray telescopes due to the large distances to these sources. Our discovery has now revealed a bright analog of these distant ULXs in our own galaxy. Cygnus X-3's outbursts are intermittent due to the elliptical orbit of the Wolf-Rayet star around the compact object. As the star gets closer, more material from the stellar wind falls onto the black hole, increasing the system's activity. IXP observed that during these high-activity phases, the degree of polarization reaches 24.9%. When the system is less active, the polarization drops to 10.4%, suggesting changes in the funnel structure in response to changing accretion rates. Veladina's team predicts that if the accretion rate drops too low, the funnel could collapse completely and only rebuild itself when accretion resumes. The team plans more observations to capture this collapse, which will be marked by the polarization dropping to almost zero, indicating that the X-ray emission is coming directly from the hot gas at the surface of the accretion disk, rather than being scattered within the funnel. This discovery not only sheds light on the mystery of Cygnus X-3, but also provides a valuable model for understanding the behavior of ULX in distant galaxies. As we continue to explore the cosmos, findings like these help us put together the complex puzzle of our universe. Thank you for joining us on this journey into the intriguing world of Cygnus X-3. If you found this video informative, please like and subscribe to our channel. Don't forget to ring the notification bell so you never miss updates on our latest discoveries. Stay curious and see you in the next video.